Hi, everyone. It's really great to be here and really grateful for being here again. Very grateful for my voice. I'm very grateful to all of you for coming to my talk. Today, I'm going to talk about how I'm working on bringing offline modes to Hotwire using service workers. I hope this is useful for anyone that have to deal with service workers or that is interested in them. They have a lot of hidden surprises. So first, let me get you up to speed on the context where we started thinking about this project. We, at 37 Signals, we have an email service called Hey, and we have two apps, one Android and one iOS, and offline mode for an email app is very important because you want to read your email while you don't have an internet connection. So each app has its own ad hoc implementation for offline. It's native, and they are totally different, the Android and the iOS, and they have been quite a source of headaches for us, especially the iOS implementation that we had to rewrite 3 times due to different problems. So yeah, we wanted to have a solution that we could use, share between the two apps. Besides that, offline mode, of course, is not exclusive to email apps. Many people building with Hotwire Native, they want to have offline mode as well. And apparently, a generic Hotwire Native solution for this has been one of the most requested features for some time. Service workers, they had been quite, like for a number of years, they had been a good established solution to have offline access for PWA. And they seem like the perfect candidate to bring this generic solution to Hotwire Native, like using this for everything, for web, for Android and iOS, in the spirit of the Hotwire ecosystem. So you may wonder, why didn't we use those when we built the mobile apps, right? The Hey apps. Well, unfortunately, these service workers weren't available in web views in iOS back at the time. They started being supported with iOS 14 in September 2020. But that was only for actual web browsers, like if your app is a web browser only, like you could request this entitlement. And this is still the case. This is a funny thing, this is still the case, but they are unofficially supported in other apps that are not web browsers, thanks to a feature called app-bound domains. And still, even with that unofficial support, WebKit implementation for service workers still had quite serious bugs until 2022. So this wasn't an option for us when we worked in the Hey email apps in 2019. So fast forward to the end of last year, then this was already stable, so it was time. I had always focus in my career in backend infrastructure projects. In the beginning, this was by chance, and then it was mostly by inertia. It was like the area I was more comfortable with. So in the beginning of this year, I talked to my boss and I said, one of my resolutions for 2025 was to get better at front-end stuff, like web APIs, JavaScript, all this. So he told me, oh, it is great. Why don't you work on adding offline support to Hotwire using service workers? So this is a great project for someone with not much experience because nobody understands service workers anyway. So I didn't suspect anything, and now I know better. Okay, so what are service workers? So a service worker is a script that runs in the browser in a background thread in a different context to the JavaScript that powers your app. It acts like a network proxy, intercepting requests and caching resources. And this enables features like offline access, background sync, or push notifications. They run in a worker context isolated from the app, which means they don't have access to the DOM or synchronous APIs. The life cycle of the service worker is often said to be the most complicated part. This is so because this life cycle makes offline first possible and also ensures that you are not running 2 different versions of your code at once. So let's see how the life cycle works. So first, when you call register, with the service worker location, with the URL, the browser fetch the scripts and execute it. So a service worker is just a script, normal script. So the browser fetch that and runs it. Then, as soon as this script is executed, the install phase happens, and an install event is sent to the service worker. Then, when the service worker is ready to intercept events, it receives an activate event. But it doesn't mean it's controlling the pages that are open with your app. When I say pages here, if you read documentation on service worker, you may see in this referral clients, pages, documents. What this means is it can be any document in a browser context, which can be a tab in the browser with your app loaded, a web view in Android or in iOS. All those are documents, clients, pages. And so you have a service worker per origin and scope, and it controls all those pages. And when I say control, that means that any fetch request happening within that page is going to be intercepted by the service worker. So for example, if in your page you are fetching an image, that request to the image will go through the service worker only if the service worker is controlling that page, okay? So after the service worker receives the activate event, it doesn't mean the pages that you have already opened, even the one that call register, it doesn't mean those are controlled. They are not controlled yet. And this is because a document or a page starts its life with or without a service worker. So for them to be controlled, they need to be reloaded or close and open again or whatever. Like they need to be reloaded again. So once you navigate away from there or reload them, then they will be controlled. And so once the service worker is active and controlling pages, it stays mostly idle. And then it's just handled, it's until an event happens, like a fetch request, a message from the main thread, or a push notification. Then you could, this is the case, but there is a way where you could bypass this behavior. You could control the not previously controlled pages right away. You will do this with clients.claim. And I've seen this used as boilerplate in many service worker examples, including AI-generated code. They usually get this like if it was a boilerplate, but it's actually not necessary, not always necessary, and sometimes it can be the source of some nasty bugs. So I advise you to understand well the life cycle and think whether you need this, you really need this, instead of just adding it to your code without knowing what you're doing. So now the update part, so when you change your service worker code and a new service worker is fetched, this cycle happens all again. But in addition, there is a waiting part where the new service worker needs to wait until the previous service worker is not controlling any pages. So all those pages need to be closed. Once of those controlled pages have closed, all service worker can be retired from can be just thrown away, and the newly installed service worker receives an activate event. And then it'll control all the pages that open after this. As before, you can skip this waiting phase by calling self.skipWaiting, but like with clients.claim, I advise you not to add this just because, but actually understanding why you are doing this and whether you need it. So this life cycle has its purpose, but it can be also a pain when developing, because every time you do changes to your service worker code, you need to do all this dance, like waiting and then closing the clients and reopening again so they are controlled and everything. Unfortunately, Chrome has this very useful setting, update on reload, which just, when reloading, it will go through this whole cycle at once, only for developing. So this is super useful. And actually, dev tools for service worker in Chrome are the best of all the browsers. You can see the life cycle, you can see events, trigger them, and inspect the JavaScript code like if you will do for your regular JavaScript code in the app. Firefox is OK-ish, not terrible, but Safari is just dismal. OK, so back to our project of adding offline mode to Hey. I decided to start small, just deploying a super simple service worker that intercepted GET requests and just showed a custom offline page whenever there is a network error, instead of the typical default browser error, like this. So I thought I would just deploy this to get familiar with this life cycle I described before. So with some help from my teammate, from my workmate Jeff, I implemented this simple service worker to start with. This is just this, on the install event here, we fetch a custom offline page and store it in the cache. Then on the fetch event, we just respond by using fetch, which forwards the request to the network. And then if there is an error, we just return the cache version of the offline page that we save. So this was it. So simple, huh? So we deployed this, and it didn't go so well. So that very simple thing broke our Android app. We got multiple reports from users that were seeing strange things, like double toolbars in several places. This happened in screens where we're using web views. Now, the reason this happened is a bit sneaky. If you're familiar with Hotwire Native, you may know that the user agent is overridden in the web app views for the Hotwire Native bridge library to find the supported bridge components. But also is overridden to let the web app know that the requests are coming from the native app rather than from a mobile web browser. Right? So this is actually parsed like this in the Turbo Rails app. This parsed like this, so you can know that the requests come from the Hotwire Native app. And this is usually to load different CSS from the web app. So you can hide some menus that actually you implement natively in your native app. And this is what we were doing here. What happened is that when the service worker was intercepting the request, it was discarding that overridden user agent in the web view and just using the default user agent in the web view. So we lose all the Hotwire Native information that we don't know. We see that as if you were using the app in the browser, in the phone. And that broke all the web view screens, like this. So this would be false, and we wouldn't know. So we have to revert that, of course, to fix the app quickly. Okay, so after reverting, so I started looking into how to make the service worker preserve the user agent in the web view. So I quickly found an idea in Stack Overflow. The idea was after registering the service worker from the main JavaScript, I will just get the overridden user agent and post a message to the service worker with that value. And like this here, this will be the custom user agent. And then in the service worker, I will, in the message event listener, I will get the user agent and I will store it in a variable here. And finally, in the fetch event, when intercepting requests, I will see if I have a user agent set, and if we do, I will just pass it over to the request using a custom header, X user agent. Why custom header, you may wonder? Why not use that, not set like the user agent in the request? Well, because of a bug, 9-year-old bug in Chromium that as of today hasn't been fixed, where with Chromium just drops the user agent, a custom user agent you set like in the fetch request. So you need to use a custom header. It's still working, it's being worked on, like the last update in this bug was from 20th August, so I'm hopeful that it will be fixed. Okay, so because of this custom header, we need a server-side change, because we need to parse this header. But anyway, I did this, and this all worked fine. So we shipped this, and everything was good, right? Well, was it? Well, okay, we'll get back to this in a bit. Okay, so now with this service worker finally deployed and running fine, I started working on the actual project, like bringing offline mode to Hey. And with the idea that once I had something working there, I will just try to backport it to Hotwire and Turbo. So the idea we had for Hey was different from other examples of offline implementation using service worker I've seen around. Usually in the examples you see, people preload a skeleton of their app with all the static files that are common to everyone. But for Hey, we wanted to do something else. So we wanted that, but we also wanted to give you your emails offline, even if you hadn't accessed them in that device. Like you may have emails that you've seen in a device or emails that just arrived, and we wanted you to have those offline before you, without you having to go to the emails and downloading it offline. So the problem is that an email is not a single resource. An email has, it has images, they can be from different origins from your app, it has attachments, and sometimes those bits are the ones that you actually want to have offline. And we also wanted to have like the possibility of users selecting tickets, travel like a label, and say, yeah, I want always all emails labeled with travel or tickets to be available offline, but without you having to go and see those emails in your device. So we wanted this. So our idea for this was to have a sort of offline manifest per user, so authenticated, where you have a list of URLs that you want to fetch beforehand without the user having to fetch them. So in the case of Hey, this will be mostly a list of email URLs, and then the service worker will go prefetch those URLs. It will parse trying to find all the resources reference in the content, like an image, will fetch that too. So when you go to the email, everything will load. Just email, the images, the attachments, everything. Just as the DOM is not available in the service worker, you don't have access to the DOM API, so you cannot rely on the browser to parse the document for you. So I implemented that just easily, just via all regexes, just scrolling the page, and allowed that to be configured in the service worker. And actually, for the attachments, that was much simpler in Rails because we use active storage, so they are stored in the database, so we could just list those together in the manifest. So I built the code for this in our app, with making this configurable by the user with offline settings and everything. So yeah, after debugging some gotchas with cores and all that, I got this working, everything. So I was really happy. It was February or the end of February, so everything worked. You will receive an email, and without doing anything, you will go offline and load the email, and it will load. So after that, I had been using Chrome only because the tools are better there. So when I had that working, basic proof of concept, I went to test on the other browsers, and also I wanted to test in the mobile apps. So I started with Firefox, and when I started working there, like nothing worked, nothing. Like nothing loaded when offline, even though I was seeing the stuff in the cache. Like I was seeing the stuff was in the cache, but nothing worked. So I started debugging. And do you remember the previous implementation that we had pushed with the overridden user agent that was storing in a variable, and so when it was received, when it was in the fetch request, I will check that. So debugging, I noticed that the user agent there it was never set. So the requests weren't being intercepted at all. So the service worker couldn't return the cache version I had, so it was always offline. So what was going on, right? It was working in Chrome perfectly. I had this working. Well, some of you may know this already, may have noticed I didn't. I was very inexperienced with this. But turns out, despite service workers appearing to be immortal in a way because they go on living even when you close all the tabs of your app, they can be stopped at any time by the browser. The browser doesn't want to waste any resources in a service worker that is not doing anything, it's just sitting there. So when sometimes it gets stopped, it doesn't mean terminated, it means just it's put to sleep, and then it's awakened when it needs to do something, like handle a request. So when this happens, the scope is reset on stop start. So it's basically as if the script is executed again, so you don't have anything in any variable, whatever there. So yeah, I didn't know this, okay, I learned, but how could this be working in Chrome? I have been doing this working, I had this working, so how? Different browsers have different thresholds for stopping a service worker. So it could be the case that Firefox was a little bit more aggressive, but it was not it, because I had been working on this for a few days, leaving this, going back the next day to work, and starting with a working prototype, so no. So it turns out that when you have the DevTools open, this stub store behavior is disabled. So obviously, yeah, I was working with the DevTools open to see everything. So, and I didn't know this, and I only found out after the fact in a random article for web.dev from 2019. So yeah, whatever. Cool. As a bonus from this, I finally understood the wait until method that is part of the extendable event, which is only available in service workers. Okay. So anyway, I have to revert this again, and thinking of another solution. So let's think together. We can't have global store state. So we need to store the user agent somewhere. where if the service worker is stopped, we can, when it wakes up to respond to a fetch event, we can get it from that somewhere and use it in the request. So, okay, let's think where we can store things in a browser. A cookie, right? Maybe a cookie. So we could perhaps use a cookie instead of a global variable. So in service workers, you have access to the cookie store API. So yeah, I could just read the value from a cookie there and just use it to respond to the request. So I tried that with very high hopes, and nope, that doesn't work because the cookie store is asynchronous in the service worker. Remember, they don't have access to the asynchronous APIs. So you get an error like this because if you try to use any asynchronous code before calling respond with, that code may finish after the initial synchronous execution of the event handler. So respond with takes a promise, so you can use asynchronous code there, but not before. You need to call respond with synchronously. Sorry. So this is actually a capture of real footage of me at that point in time. But anyway, that failed cookie approach gave me another idea. Let's use a cookie, but let the main thread set it like this. So right after before registering the service worker, I will set this cookie and just let it be sent with all the other cookies, like authentication cookies and stuff. And then in the server, we just read the cookie. So the service worker is not the wise, like he doesn't know anything about the cookie. And yes, this worked. And we deployed that, and we haven't had to revert this, so third time must be the charm. Cool. So now we are ready to handle one of the hard things in computer science. So if you are caching things, inevitably you will need to do cache invalidation. So in the case of Hey, it's a bit tricky because we are catching things before the user sees them. And also, for example, if you are you have an email that you are catching and there is a new reply that arrives, we want to refresh that because to show you the very last version. Or if you delete an email, we don't want to cache that email anymore. So we have to do this out of band without the user doing anything. So yeah, so after some trial of an error, I got this implemented in this way. First, I extended the offline manifest with information about when a particular resource got last updated. So this covers the case where an email receives a reply, for example. So they need to be refreshed. And some elements, like images or attachments in email, they are immutable. Then, on the service worker side, I had to store the last time we had fetched each URL. So I could compare that with the value in the manifest to know if I needed to refresh it. This is like a sort of cache registry that I implemented using IndexedDB. This is not enough. You need to know to tell the service worker when it needs to reload the manifest, somehow, or to reload specific URLs. So the way I did this was by triggering a message from the main app to tell the service worker that it should reload and reprocess the manifest. This can be done after some event. For example, after a user goes and changes the offline settings to say, OK, I no longer want to have the tickets label offline. So I could use that as an event to trigger that to the service worker and reload the manifest. Or it could be done after some, you could include a custom DOM element. I don't know, this case. So I did it using a custom offline element that I will return in the HTML response after some event from the user. And I use this in the case of updating the offline settings. Another way I did this as well was sending an update via action cable. So we were already using turbo streams. We are already using them in the mail app. When a new reply arrives into a thread, we broadcast the update to the thread in question. So if you have the app open, you will see the reply arriving there. So I used the same idea, and I created a new action cable channel just for offline updates. Then I reused the previous custom HTML element to store the signed stream name and to manage the channel subscription. And then it was more or less straightforward. I will get the cable connection from Turbo, and then in the HTML connected callback of this custom element, I will subscribe to the channel, to the offline updates channel, which is this one. And then when receiving a message through that channel, I will just relay it to the service worker. So for example, to reload the manifest. And yeah, so this is the message sent to the service worker. And we could trigger them from the backend code, for example, when a new email is received. And it could be extended to do like reloading anything on demand. So you may wonder now here, what is this with this proof of concept, that? Well, by the end of March, so I submitted a talk to this conference with this, describing this work that I was planning to finish launch for Hotwire. But actually, I greatly underestimate the amount of work I will have to do, not just for this, but just in general, like a lot of different work that I usually do. So I was working on this on the side, totally on the side, and neglecting it for weeks and weeks. And so it was already July. Suddenly it was July, and I didn't have anything, just the proof of concept. And so I thought, okay, I'm going to simulate my own death and go live in the mountains with no internet. But then I thought, well, if I don't have internet, then offline mode actually will be very useful. So I said, okay, I'll go back to work. And thankfully, I got in a call when I was very, freaking out. I got in a call with Joe Macelotti. You know him, he's the guy to go for all the things Hotwire Native. He gave a great keynote yesterday. So he told me, I told him all this story, he told me, if you just implement that offline mode for the stuff you've accessed, like just on visits, that the simple way, that already be enough for many people using Hotwire Native. So, and I already had all the pieces. They were just a bit lost in a proof of concept mess, but they were there. So after I spent a few long days extracting and cleaning all that, and adding simple cache expiration for that, because if you only cache things as you access them, it's so much easier to invalidate the cache, because you can use those actions to invalidate that cache. You don't need to do it out of band cache invalidation. So I got a pull request in Turbo that I plan to use as the basis to build the rest. This PR is the sort of phase one of basic offline support. It's quite similar to a subset of Workbox. You may have used, if you are working with service workers, you may know this library by Google, by the Chromium team. But this in Turbo is way simpler and much lighter. With this, you just basically import the new Turbo offline script in your service worker, add some caching rules like this. You can configure which URLs you want to be intercept and cache. And you can choose a strategy to cache, like network first, stale while revalidate, or cache first, and then configure a max age for cache entries. And yeah, the cache invalidation is much simpler to do. Then for the phase two, the advanced offline support, I plan to incorporate everything I described before with the offline manifest, the out-of-band caching, and the action cable, the action cable messages to invalidate things on demand. And also, I plan to get a way to configure all this easily in the Turbo Rails library without having to write almost any JavaScript, like with some helpers there. Yeah, like with this, the Turbo offline thing and everything. So to sum up, the next plans for Hotwire, for offline mode for Hotwire, I need to get the Turbo PR merge and the small changes in the other repos to support this. I need to finish replacing the native implementations we still have in our Hey apps with this approach, and then upstream all of that to Turbo. That will be the phase two. And I won't make any promises of when this will happen. I will just say soon. David yesterday said soon, so yeah, soon. The APIs are still not fixed, like the pull request is open. So if you have any ideas about how you would like this to be, talk to me, or now, or so today, or comment in the pull request, whatever. And so about conference-driven development, I tried. I don't recommend this methodology unless you hate yourself and you want to make your future self miserable and unable to function in society for 1 month before the conference. And that's it. Thank you very much.